particle is projected from a point O on horizontal ground at an angle of theta to the horizontal and an initial speed of u meters per second. Find the time taken for it to reach its greatest height. Okay, so this is a completely generalized projectile, and we are being asked to find the greatest height. We also need to find something here, and in the next example we need to find something else. That is something that you need to be able to derive in the exam. So let's have a look at how it's done. So we're just going to look at the horizontal motion of the projectile first of all. S, U, V, A and T. Now what do we know from this? We know that U is capital U cos theta, and we know that the acceleration is 0, so we actually also know that the final velocity is also going to be capital U cos theta, and that's all we know at this point. Taking a look at the vertical motion of the projectile, S, U, V, A and T, we know that straight away that A is negative G, we're taking up to be positive. We know that U equals U sine theta, and because we're looking for the time taken to reach the greatest height, we know that actually the velocity is 0. Okay, so all we need to do to find the time taken is to do V equals U plus AT in this vertical motion. So let's take V equals U plus AT, which means 0 equals U sine theta, take away GT, and then T is clearly going to be U over G sine theta. Okay, on to the next part of the question. By first showing that its range is given by the formula U squared sine 2 theta over G, determine the angle which will give the maximum possible range. So this is actually the third thing that you need to be able to derive. The second thing you need to be able to derive, we're going to use to derive this. So the second thing, the thing that we're actually going to use is we're looking at the range of the distance, the horizontal distance. So we're looking at the total flight. So in that case, the that's going to be twice the flight of this. So I can now do the whole question. I'm not going to have V equals to 0 anymore. I'm actually going to have S equals to 0, and I already know that T is just going to be equal to 2 lots of this, so it's going to be 2U over G sine theta. So let's write that in as 2U over G sine theta. And we just know that from symmetry. So if you're asked to work this out from scratch without having to work this out, you could actually use a different way. If we take these, if we haven't worked out the time to the greatest height, we could actually do it, and I'll just do it over here to show you. We know that G acceleration is minus G, this is U sine theta, and that is S. We can now find T by doing S equals UT plus a half AT squared. So S equals UT plus a half AT squared. We know S is equal to 0. UT is going to be U sine theta T. A half A is going to be minus G over 2 T squared. And now this is just a simple quadratic to solve, which is going to be U sine theta take away G over 2t. Clearly this one gives the solution that t equals 0, which is obvious because at time t equals 0 the particle has not moved up or down. Or if I solve this, I'm going to get U sine theta times 2 over G, so 2U over G sine theta. So we're getting the same result as up here just by doubling that, and you can actually get this obviously by doing this and halving it, up to you. But if you're asked to do this without having done this bit, you might want to do it this way. Either way, you get to a point where you have this information, and we want to work out the the maximum possible range, given that we first of all want to work out this Sx. So Sx is going to be down here, S equals ut plus a half at squared. A is 0, so that gets rid of that. So S is actually just going to be u, which is u cos theta, times by t, and we now know that t is 2u over g sine theta. And if we have a look at what we're trying to make that equal to, we can see that the biggest difference here is we've got thetas, and here we've got 2 thetas. So we're going to make the arguments the same, and you should be able to spot that 2 sine theta cos theta leads us to the double angle formula. So if we extract everything else out, we've got u squared over g times by 2 sine theta cos theta. So that now becomes u squared over g sine of 2 theta. So that is one of the things that you have to be able to derive in the exam. So you'd be able to derive this, this, and this. But the actual question is, what's the maximum possible range? What's the maximum possible value of S? Well, as this is a constant, and this is a constant, the maximum of S is when sine 2 theta is maximum, and sine 2 theta is maximum when sine 2 theta equals 1. Inverse sine of both sides, you get 2 theta equals 90 degrees and theta equals 45. So we have shown there that if you want to throw something as far as possible and you're going to throw it at a certain speed, the furthest you'll throw it is if you throw it at 45 degrees.